Good afternoon, I'm Cataldo from the University of Bari, and will present a work about personalization in cultural heritage domain through a content-based recommender system called FIRST. Okay, what are our research motivation? What are the basis for what we make? First one is an information, a knowledge from almost 4 decades, and is that in cultural heritage domain, we have to provide users digital access to content of collection to improve user experience with the whole corpus contained collection. Second information, and that's a more recent thing, is that this access to cultural heritage collections must be not only digital, but also personalized. What does personalized mean? It means that we have to manage some way, we have to provide some way to acquire user preference. This information stored in a user profile, building, for example, a personalized museum tour, or filtering from collection. All of course, we can think user or visitor can be interested in. For example, this can be made with a recommender system. Presently, Web 2.0 evolution changed some way the game for personalization. What does in Web 2.0 platform happens? So substantially, in Web 2.0 changed user role in web dynamics, because in this platform, as you will see, user is no more a simple consumer of information as the one created. In Web 2.0, user can also be a creator of information. He can create new data, he can create new information, he can share this information with other people. So our conclusion is that we have to study, we have to analyze user-generated content, because it gives us some important information about user preferences, information that can be useful for personalization work. So, in this work, we will begin to investigate how to combine this user-generated content, information combined from user-generated content, with content. I will start with a brief description of Web 2.0 term with user-generated content. Then I will introduce architecture of our recommender system called FIRST. Then I will show results of an experimental evaluation made on a vertical picture gallery dataset. Then I will conclude with study findings and discussion. Okay, Web 2.0. What does change with Web 2.0? As I said, in Web 2.0 platforms, like YouTube, Facebook, WordPress, etc., users can create new content, can share content create with other people, with other users of these platforms. Users of Web 2.0 platforms are no more simple consumers of information, they became active producers of information they produce. What kind of content they can create on this platform? Heterogeneous content. They can create photos on Flickr, they can produce videos for YouTube, for example, blog posts on WordPress, or they can also annotate web resources on a platform like Delicious. So, term user-generated content is used to describe the set of all content a user can create on this platform. So, through this words and disambiguation procedure, we some way change text representation. We shift from a representation based on simple words to a representation based on a syntax. A syntax is a numerical value that identifies meaning of word inserted in text. In the same way, we also shift from text to semantic text. So we have semantic text and disambiguated document as output of this content analyzing procedure. we use this information as input for the second step of our recommendation process. That is profile learning phase. In this phase, we use all user rating we acquire during training phase. We store all this information about user interest, user ratings in a user profile, and we will see in the next slide, we will use this information in the recommendation process. Learning phase is performed in this way. We have a set of synthetic indexed training documents. For example, in this case, document 1, document 2, and document 3. To every document is associated a rating. For example, as I said, on a 5-point rating scale. This information about user preferences are stored through this profile learner in a user profile. We store the information that user likes document 1 and document 2, and it doesn't like document 3. Build this user profile, we exploit information previously stored in the recommendation phase. Recommender system is built in a probabilistic way, like a text categorization based algorithm. We exploiting, as I said, information stored in user profile, we can classify every other document the user has not previously rated as interesting or not interesting for him. Recommendation phase work in this way. We have some docs to be classified, for example, document 6, 8, and 9. We have a recommender system and a user profile. Through the information stored in user profile, we can give a numerical estimation of user interest in this item, in this document, in our case, in this artwork. That's the probability the user like this document. For example, in an intuitive way, if during the training phase I rate on a machine learning approach where user profiles are inferred from both static and generated content and user-generated content. Main outcome of this paper is that the integration of user-generated content causes an increase of precision of recommender system in recommendation artifacts to users. What are our future work? We have to make some other analysis on results that emerge from this experimentation, because results of social type are some way under expectation, because we originally think that profile built with social type will be one with the highest precision and recall. Instead, it was lower than other classes. Further steps are also an analysis on what type user uses to annotate artworks, and try to find a relation between type usage and user profile generation. Last step is the replication of this experiment with a more heterogeneous community involving, for example, art experts and studying if differences in language that characterize simple museum visitors and art experts can some way change predictive accuracy of this system. Thanks for your attention.